All right. Happy Wednesday, everybody. I'm Julia Geiswhite. And I've got with
I'm Emmy LaFountain.
you guys have heard from us on past webinars, so we're really excited to come to you for this episode 2 of our Green Construction webinar series for 2021. As you may have heard from Emmy during episode 1 back in January, this year we're going to explore some of the various aspects of sustainability in the built environment, mainly around carbon, but that may be in the building materials that we use or in the construction process itself. Today we're going to talk about our Jobsite metering program, which is now 2 years young. And last month we shared some of the findings out of the first cohort of projects that have gone through the program. We had over 70 projects participating in the program to date, which means we've actually started to amass a large amount of data. And some of you on the call may have participated in that earliest pilot group and hobbled through some of the growing pains with us along the way during those early months. If that was you, thank you. Others of you may be mid-project, actively gathering data. And then others of you may be brand new and being introduced to the metering program for the first time today. But that's okay, because today we're going to go back to basics and we're going to talk about the why, the when, the how, the who, and the how much. We're also going to talk about some of the PDCA that we've done along the way to help streamline the process and maximize the value that we're getting out of the program. So Emmy, if you could go to the next slide. Okay, this is how we are going to flow today. We're going to start with a refresher of the origin of our metering program, and that's going to help ground us and kind of bring us back to the why behind why we're doing it. We're then going to share some of the changes you can expect in 2021. Don't worry if you're new to or unfamiliar with how things worked in the past. The rest of this hour, we're going to get you up to speed. And then from there, we're going to go into the nuts and bolts of how the whole thing comes together from setup and launch to the actual hardware and software that we use. Next slide, Emmy. Okay, so why meter? And I'm going to kind of go answer this question in a roundabout way, but the context is really important, so bear with me over the next couple of slides. All right, I'd like everyone to digest this graphic for a minute. The gist of what you're seeing in that half moon shaped wedge with the dotted outline, that's the building and construction sector, and it stands as the world's single largest emitter of carbon emissions. So when you add up the operation of buildings, the production of building materials, and the process itself, the construction itself, you're looking at about 60% of the greenhouse gas emissions in any given year. 60%, okay? So forget about what's coming out of your tailpipes or everything you guys know about big oil. The single biggest way we can curb climate change is through, guess what? The work we do as an industry every single day. And so there's a UN body, it's called the IPCC, that stands for the Intergovernmental Panel on Climate Change. And they exist solely to evaluate the current impacts and the future risks of our changing climate. And essentially what the IPCC did a couple of years back was issue sort of an ultimatum. And what they said is that for 1.5 degrees Celsius, a little under 3 degrees Fahrenheit of additional global warming, that will be the tipping point for which some pretty devastating things are going to happen. Coral reefs will start to be wiped out. A lot of our natural ecosystems are going to start to decay. Drought periods will become longer. Weather conditions are going to be more extreme on both ends of the scale. Basically, our climate systems will swing way out of balance. And that is compared to pre-industrial levels. So think late 1800s or so. And so for perspective, we've gone up about 1 degree C in the last 100 years, but that rate has really accelerated in the last 30 years or so. Now, to avoid that 1.5 degree threshold, the built environment essentially needs to go carbon neutral by the year 2050. And depending on who you ask, it's got to happen even sooner than that. So that's 30 years from now. That's 29 years from now. It's not too far off in the scheme of things. And what's kind of even scarier about it is that not even 1% of buildings today are considered net zero or net positive. So what that means is that we have a lot of work to do and not very much time to do it. And because of who Turner is, and because of the work that we do is 60% of the problem, and because of our size and because of our presence, and because really we always lead when it comes to doing the right thing, we have a responsibility to make headway in this fight against global warming. So Emmy, go to the next slide if you don't mind. So let's break down for just a minute what we mean by the built environment and the 60% that we're talking about. And to do that, we have to think about the entire life cycle of a building. So greenhouse gas emissions are generated at every step along the way. The extraction of raw materials generates emissions, the transportation of goods, the construction process, the operation of the building over its lifetime, of course, and even the eventual deconstruction 100 years from now. It's all included, and it's a lot of greenhouse gases that are going into our atmosphere. A common way that the industry likes to kind of represent these phases is shown in the graphic on the right. And each individual step or stage, as they're referred to, is designated a number. So A1, A2, A3, B1, B2, B3, etc. Now, Emmy, if you could go to the next slide. Now, in all our daily operations at Turner, we can directly impact the emissions that are produced in stages A5. If you see it there highlighted on the top, those are the construction activities that happen within the job site fence. And we can sometimes impact the C1 activities as well, because a lot of our projects involve the demolition of existing buildings at the end of their useful life. And because we can collaborate with our trade partners to directly influence the carbon and water use in these two stages, we felt pretty comfortable being able to make a public commitment around the activities that happen within Turner site gates. And there you have it, our 2030 commitment was born. So we committed to reducing the greenhouse gas emissions and water consumption of our on-site operations by 50% by 2030. And we like to think of the metering program as kind of the first phase in the pursuit of this target. So Emmy, next slide. So not only is the data from our first 2 years of the program going to help establish a baseline against that progressive reduction that we're going to have to hit, but it also helps shed light on the sources and the trends of what kinds of energy we use and how we use it. At this point, because of this metering program, we know more than any other company out there about where and when our energy and water is being consumed and at what relative intensities. And this information is gold because it helps prioritize our efforts for impactful reduction. Basically, it's about how we get the biggest bang for our carbon buck. Okay, next slide, Emmy. Okay, so how do we do it? And Emmy is going to go into a deeper dive on the how, but generally there are two methods that we use to gather the data. The first method we refer to is measuring, and this is the collection of data in the form of utility bills and fuel logs that we typically have access to anyway. These documents are usually available on a monthly basis, and they give us a picture of our month-to-month use, but not much more granular than that. That said, measuring does offer a fairly complete picture of how much energy and water a project uses from start to finish. The other method that we use is live metering, and that involves the installation of sub-metering hardware to track our energy and water. And what live metering does, it allows us to examine the trends in increments as small as 15 minutes so that we can see how our consumption changes over the course of a week, a day, even within an hour. And metering also allows us to distinguish between the various sources. So say lighting, cranes, trailers, hoists, you name it. Okay, Emmy, next slide. So now that you guys have a good basis of the understanding of why we meter and our two methods for collecting the data, let's talk about what's going to be new in 2021. Next slide. Okay, going forward, a standard course of business within Turner. All projects over $10 million are going to be considered for metering. Now, we do have some guidelines that's going to help determine whether or not your project is a good metering candidate, and because all projects are not great candidates. So Emmy's going to explain more on that in a few minutes. But if a project is deemed to be a good candidate, the tiered structure that you guys see on the screen here is going to apply. So jobs up to $10 million will be able to make their own decisions about whether or not to participate. The idea here is that these are sometimes smaller jobs, often TI projects or smaller, faster ground ups, where it can be difficult to submeter, or they happen too quickly to get things up and running. So guys, we heard you and understand the real obstacles here, and therefore $0 to $10 million optional. Projects in the $10 to $50 million range will be asked to participate in a measuring capacity. So if you remember from just a few minutes ago, That means collecting utility bills and entering them into our BuildingOS platform. So no hardware to buy, no hardware to install. And the cost savings for projects in this range are pretty significant compared to the way we've done it in the past. And then moving on to jobs that are $50 million plus. This is where we're going to maintain our metering approach with sub-metering hardware, and we procure that through our partner Vitality Energy. These projects are also going to be asked to collect utility bills as well as implement one strategy to reduce the project's energy or water use. And then finally, for all projects, we've added a suggested innovation hold, and that's in place to facilitate the implementation of new strategies or technologies or solutions that can be tested and then shared across Turner. So more on that innovation hold in a few slides. Hold the thought. Okay, so we've been continually assessing and improving our metering program over the last 2 years. Here are a few of the improvements that have really made things easier for project teams. But in the interest of time, I'm not going to go into detail on each one. But the bottom line is that we're working on solutions that save time, that save money, and that save headaches. So please continue to send us feedback so that we can continue to make changes for the better. All right, next slide, Emmy. Okay, the $1 million question you guys have all been waiting for. What's it gonna cost me, right? Oh, there are definitely some improvements here too. So jobs in the $10 to $50 million range should expect to pay about $10 a month for the metering software, plus the recommended hold for sustainability, which again, we'll discuss in a minute. Compared to the average project costs in 19 and 20, that's a pretty big improvement, even with that hold added in. For jobs over $50 million, we've estimated about $15,000 to $20,000 over a 2-year job that has a fairly simple utility setup. Now, this is gonna vary a little bit depending on the logistics of your site. And again, that number also has that $5,000 hold. Okay, so let's talk about that hold for a minute. Next slide, Emmy. Okay, as we said, the idea here is to provide an avenue for teams to get creative with the way that we can reduce emissions in water and help us achieve our 2030 commitment. We've provided some ideas on TKN, or you can rewatch the January webinar for some inspiration, things that are already being piloted on jobs across the country. This could be small things like applications for inside the project trailer, or it could be larger concepts for things like hybrid generators, PV panels, water saving devices, what have you. But we do encourage you to come up with your own solutions that work for your particular project, and encourage you to get your sub-partners engaged to participate in that brainstorming process. Have fun with it and share your ideas with us, and as well as your successes. Okay, I'm going to turn it over to Emmy now to explain how to set up your project for maximum metering success. Emmy?
All right, thanks. Hopefully you can hear me. So I'm going to be getting a little bit more into the nitty-gritty about how to get metering launched on the project. Recall that metering is only required for projects over $50 million that meet, the right criteria for participation. So this next section I'm going to dive into has more to do with the actual hardware and the process behind getting it installed. So the first step in that process is to include costs and language. And this is really directed more towards pre-construction and procurement. But the idea is that it really needs to be captured early on in the process. So as Julia went over before, the kind of high level costs can be generalized around kind of the $5,000 range for projects $10 to $50 million, and over $50 million kind of in the $15,000 to $20,000 range. Again, the caveat here is that this is really assumed for a 2-year project with a really basic utility infrastructure. If you want a more specific idea of how much your project would cost in terms of metering, feel free to reach out to your sustainability manager and we can give you a better answer on that. The other element you're going to have to capture early on is the scope language. So this is standard field tracking and meter install language that can be inserted into your contracts early on in the process. It can be found as a template on TKN, or it can be handed to you by your sustainability manager. Our recommendation is that if you're a pre-construction manager, go ahead and stick this in your standard templates in your business units now, because it's going to be easier to delete this language later than to add it later. And this is all very important language to make sure you don't get hit with change orders later on in the project. Step number 2 is that not every project is a great candidate for metering. So you'll want to confirm participation by first connecting with your sustainability manager. And that sustainability manager is going to ask for information on the project, like information about the boundaries, how many stories it is, utility layout, etc., and communicate that information back to headquarters. Then headquarters is going to provide the final recommendations to the ops manager, who has the final say on the go, no-go status of metering on that project. Now, like I said, not every project is a great candidate. Ideally, we look for 3 main things. And one of those is access to monthly utility bills from the start to the end of the project. This is really important for a few reasons. One of the reasons is that we kind of use the bills as the Bible in terms of the true usage of consumption on a project. So from shovels and ground until substantial completion, what is that total consumption? So if you do install meters, maybe like a month later, maybe the meters go down, you're not depending on those meters for your total consumption over the life of the project. So that's going to be really important. The other reason that the utility bills are really important is it helps us calibrate our meters. So once we install the meters, making sure that for the same duration, we're reading generally in the same range as what the bills tell us for that same period. So that's going to be important whether or not it's a metering project. A second really good candidate is one that can be easily distinguished from other buildings and floors. So for example, if you have a campus project where you're putting up 3 buildings and maybe each of the buildings is getting turned over at different times, it's going to be pretty hard to distinguish your building's information from maybe the second building in the phase. So phase projects can be difficult. Generally what we like to see is basically if you can draw a line around the project boundary, that's kind of the good idea of if it's going to be a good candidate or not. So another example is airports can be really difficult because if you're tying into an existing terminal and you're sharing some of the utilities with the operating space, you're not going to be able to necessarily distinguish your usage from those other areas. Now, this doesn't mean that you can't meter on those types of projects. It just makes it a little bit more difficult. And in some cases, you know, if it's a really green client or it's a really high profile project, we'll figure out a workaround. And then a third good candidate is one where there aren't many other general contractors working within the project boundary. So for example, if you're working on a big core and shell project and a year before substantial completion, other contractors start coming in to work on the TI space, that's going to make it really difficult to distinguish from the utilities how much of this is Turner's responsibility versus the other contractors' contributions to the utility consumption during that handover phase. So like I said, this doesn't necessarily mean we won't do metering on it. If there's a big desire to do metering on that, we can certainly facilitate. But generally, these kinds of projects that don't meet these criteria are not going to be recommended to the ops manager for pursuit. Step number 3 is to obtain logistics documents. And typically what we'll ask for is 2 logistics documents. One of those is the temporary OneLine diagram, and one of those is the logistics plan. The logistics plan is really straightforward. It's basically just going to be your standard site logistics plan with utility connection locations marked off. You know, where is your trailer? How far are you from the actual distribution gear, etc. The other part of this is the OneLine diagram, and especially if you're a younger engineer, you're not as familiar about this. I want to kind of demystify that a little bit for you. But the OneLine diagram is going to be really important for a few reasons. And before we get into that, I wanted to just note a few important points about the OneLine diagram. Number 1 is that it's really important to get this early so that we can understand when temp power is scheduled to come online. What we don't want to do is to have the temp power come online and then put the meters in, because you're going to have to schedule a shutdown. It might be a little bit disruptive to the flow of work. And you're also going to be missing some of that early phase data, which is something that we want to get. So ideally, we can identify the required on job date for those meters. And you can expect kind of a lead time of about 4 to 6 weeks, depending on the intensity of the meter layout that we're looking for. Another comment that we get a lot about this is there's already a meter on our project. So why are we adding additional meters? And you know, we had spoken previously about the importance of getting those monthly bills. If you'll recall, this meter is installed by the utility company just for billing purposes, and this will give you either a monthly bill with a single number of consumption, or best case scenario, it might already be a pulse meter that gives you a single usage. So this is really valuable. I mean, it's really great that the cities are transitioning towards this, but what it'll give you is just a single line, right? Because this is installed at the main for your project. And so if you say, oh, wow, that's really interesting. We're using 60 to 70% of our electricity off hours. That's great. What is it? It doesn't really get much more granular than that. Now, with our metering program, we are trying to get more granular to a point where we don't just say, oh, that's a pretty graph, but we also say, all right, we know that we're using 60 to 70% of our electricity off hours. And the reason that it's being used is because our temp trailer heaters are being left on overnight. Or, you know, our lighting is being left on overnight when nobody's there. So this helps us get a lot more granular with that multi-circuit meter. Now, when we talk about a multi-circuit meter, again, this is an effort to help demystify the OneLine diagram for some of the younger engineers on the call. This OneLine diagram can be worked out with your electrician for temporary power distribution needs during construction. So this is going to be different from your permanent power meter needs. So this OneLine diagram can be developed to identify the different uses of electricity on site. So for example, you can identify on this one, they called out the fire protection pump, the man lifts, the sump pumps, the dewatering controls, the cranes, some welders. These are really just ultimately the major loads of electricity on the job site. So those major electrical uses that we would ask to sub-meter include the trailer, pumps, man lifts, cranes, welding, general power, lighting, hoists, etc. So these are basically just the main uses of electricity on the job site. And so if you've got something that dictates its own circuit, we would want to put a name to it and identify that's consumption trend. And the way that we measure that is using something called a current transformer, or CT, or colloquially it's referred to as Joe amps. So these are literally amp reading clamps that go around each of these circuits. And then they can actually pull that information in individually. So at the end of the day, when you get it, it'll look like this special graph that highlights those different loads. So the next step would be to hold a meter selection call. We use a company called Vitality that Julia had mentioned before. This company has been ordering the meters on our behalf. They're very familiar with our program, and they do all the commissioning needs for your project as well. Now, by no means do I want to say you have to use Vitality. I know in the spirit of competition and having competitive bids, I absolutely welcome you guys to go to the solution that works best for your job site. You can piecemeal it together. You can order the meters yourself. You can have your electricians figure out how to make it communicate to the cloud. I will say that Vitality has kind of been the easy button for us. And this will be kind of the default that we tend to turn to just because they're very familiar with our program. But if you're interested in other ways of getting metering installed on your job site, we can communicate that early on and take that route accordingly. But the meter selection call will be important. They'll take those two logistics documents that we discussed earlier on, and they'll say, all right, well, based on the layout that you currently have, we're going to need this many meters, etc. They'll ship it out to you. And then the next step is to have a pre-installation call. So this is a really great checklist that we go through with the electrician and Vitality on the phone. This is just to go through the order of operations so that when game day comes, everybody is ready. They already know all the requirements for installation on the job site, and it goes by trouble-free. And so when it is time for installation and commissioning, your electricians and plumbers are going to be the ones to install these units. Vitality will not be coming out to do that for you. It will be done by your electricians and plumbers. And they'll be on the phone with Vitality, and the Vitality will say, you know, push these buttons in this sequence. It should flash up this many times. And once it's up and running and online, Vitality will then make those connections into the cloud so that it shows up on BuildingOS for you. So I know that we just went through a lot of steps. Keep in mind that when we actually get your project started on metering, I will be on, or a sustainability manager will be on to help walk through this process as well. So we're not necessarily expecting you to memorize this. Let's talk a little bit about the hardware. And this is, again, going to get a little bit into the nuts and bolts, but it's going to be pretty important to understand how these things communicate with each other. So if you take a big step back, the important thing to remember is that the systems that we use right now, which we use obvious meters for the most part, the way that they communicate is via radio. And you have your metering points on the field, and they send the information over radio to a data receiver hub in the trailer. So let's take a deeper look. Now, if you recall back to that OneLine diagram, we've identified all the different circuits at the distribution gear. We've got the CT clamps going around each of those different circuits. Those CTs are going to be wired into something called a multi-circuit meter. And a multi-circuit meter basically is just a regular meter, but it has multiple inputs for those different circuits so that it can separate that data and send it out to the cloud as different points to monitor. This is ultimately a lot more cost effective than ordering multiple single circuit meters. So this is the reason why we went that direction. That multi-circuit meter is going to then have to send out that information. And the way that it does that is by being connected to basically a walkie-talkie. And in this meter model, we use something called mod hopper, but it's just a radio. And those are going to be connected using something called RS-485 cabling. Now, that's not going to be really important for you guys on this call, but it will kind of be important to your electricians. So when they ask the question, they're going to want to know exactly how these things get hardwired together and if they're going to have to do that themselves. So this is what sits out in the trailer, out in the field. Now that signal gets sent out and then it gets picked up by another radio that's connected to a data receiver. And this is all sitting in a single box in your trailer. And that data receiver is what takes that information, turns it into hex code, and then makes it compatible for upload into the World Wide Web. And so this box is going to be sitting in your trailer. Again, these two units are hardwired together using that RS-485 cabling. And then this box is going to be plugged into the Ethernet cable in your trailer. So that's how it talks to the cloud. The same thing can be said about a water meter. So if you just replace that electrical meter with a water meter, it takes that, that flow rate, converts it into digital signal, sends it out over the cloud, over the radio. The difference to note about the water meter is that it has to have electricity fed to it because it's not sitting at a distribution gear. So in order for the water meter to run and the mod hopper to run as well, it's going to need some power fed to it. So that'll be a specific logistical need on your job site. Now, if your water hydrants are way too far away from any kind of power source, it may not be practical to run electricity to it. And in those instances, we might actually suggest just go ahead and read that manually. You could throw a dumb magnetic meter on it, go out and read it once a month. But ideally, we would start kind of with a digital model. And then if it's not logistically feasible, then we might back away and say, go ahead and read it. So again, putting all the pieces together, you've got your metering points out in the field. They're hooked into radios. Those radios send that information to another radio. This distance should be about 500 feet. If not, you might need a repeater in there, but that other radio catches it and sends it up into the cloud. So hopefully that helps to kind of demystify how these units talk to each other. Again, we will be there with you every step of the way. So if you don't remember this all today, it's not the end of the world. So let's talk about once it gets sent up into the cloud. Let's talk about how we visualize that. And so the software that we use is something called BuildingOS. Sometimes we refer to it as Lucid as well. Lucid is the company that makes BuildingOS. So we might use it interchangeably. But basically, this is a software platform that's open on the web. We have a main Turner account. And from that account, we can see all of the projects that are being metered and measured at Turner Construction. So it'll be really cool. You can actually see all the other projects that are in your region, see how you compare to comparable projects, etc. But this is a really great platform for us because it's a way to aggregate that live meter feed from the field. So you can see when you have live water wastage or when you have electricity being used overnight, you can visualize that here. But it's also really great for purposes because you can input fuel tickets and everything, and it'll already convert it into tons of carbon for you on it. So ultimately, when we're doing this program, we only care about two things. We care about carbon and we care about water. And so this will help us visualize both of those metrics. Now, the element that we didn't talk about too much before because we were focused on metering is the measuring aspect of it. it's really easy to measure this usage. When you, for example, get fuel tickets from your subcontractors, you will hand them this standard fuel tracking form. They'll fill it out. We used 400 gallons of diesel this month. They'll send it back to you. And then the entry is just calendar date 1, calendar date 2, usage save. And that's all you really need to do from an entry perspective. So it's pretty simple. Same thing can be said about utility meters. And at the end of the day, what you'll get is this pretty looking graph. It'll tell you what the biggest portion of the pie is in terms of consumption on your job site, which is ultimately what we're really interested in, because from a reduction standpoint, we really want to tackle the biggest chunk of the pie first to make the biggest impact as soon as possible. Something that's really cool about this platform too is that sure, it'll take, convert your gallons of fuel into carbon. But another really great thing is that it'll take how many kilowatt hours you guys used. And based on your zip code, it will convert that into tons of carbon as well. And that's a really important feature because, a kilowatt hour of electricity made in Washington, where there's tons of hydroelectric, is going to have a much lower carbon footprint than a kilowatt hour in West Virginia, where they're going to be really coal dependent. So this takes regionality into account. So you'll find that the electricity footprint for projects kind of more on the East Coast area of the country generally are going to be much higher than those on the West Coast. So this is really an important way to visualize that information. Okay, let's dive into team roles and responsibilities. And I'll try to go through this in a rather digestible way. I know there's a lot of words on the screen, but let's go ahead and start with pre-construction. So if you're in pre-construction, you're going to have kind of 2 primary responsibilities. And one of those responsibilities is to make sure that you capture those costs that we talked about earlier on with Julia, and make sure those are captured in the GMP, so that it's not going to be a nasty surprise later on that you're being hit with, 16 grand in meter costs, for example. Another thing that's going to be important to do if you're in pre-construction is collaborate with that sustainability manager to verify the candidacy of your project. So we went through that process of communication, but the sustainability manager, each sustainability manager has a different role within the business unit. They might not be savvy to the latest in business development or recent wins. So they're going to depend on you guys, if you're in pre-construction, to supply them with that information. If you're in procurement, I would say that the most important thing is to capture that metering language in the scopes of work. Like I said, if you can get that into your standard business unit templates, that's going to make life much easier later on. You can delete it if it doesn't apply, but this hopefully will become a fairly easy lift later on as it becomes standardized within our business units. If you're an MEP engineer, there are 3 asks for you on a project. One is making sure to get that OneLine diagram. And if you can get it early on enough in the project and work with your electrician to develop that, making sure that we're making those circuits according to those different load needs that we want to monitor. The second thing that we're going to ask you to do is to help procure and facilitate the procurement of the meters. Again, if you're not in that 50 million plus range, not a big deal. It's going to be all manual, so you don't have to worry about that as much. But if it is in that 50 million plus range and you are getting meters, it will kind of take some more hands-on interaction with that electrician and plumber. And the third thing is, say you do realize that there's a ton of electricity being used overnight by the temp lighting circuit. We will hopefully ask you to address that utility waste because we don't want to put all this effort and time and money into a system that's ultimately not going to be used to the benefit of the job site. When we identify this for the purposes of carbon, underneath that layer, we're also addressing cost, right? Because if we save a kilowatt hour here, not only is that a ton of carbon reduced, but it's also money saved for the client. If you're a superintendent, again, 3 things to ask from you. One is to help identify the metering points on a logistics plan. Hopefully you already have that on your logistics plan, so it's more of just getting it in the hands of the sustainability manager. Number 2 is to help facilitate installation. So come time game day, that you're talking to your electricians and plumbers and making sure that they've had that pre-install meeting, that they have the checklist in hand when they're doing that and they're on the phone, and that they have all the parts and pieces necessary to ensure success. And another important thing is to help attend metering check-ins. These are going to be held once a month with a sustainability manager and headquarters to ensure that we're QA/QCing the data that we're getting. You know, if, for example, a field engineer is putting in all the data, they might not have the complete picture of what's happening in the field. So assigning actual activities to the data that we're seeing is going to be really important for headquarters to now direct kind of the future of sustainability programs at Turner. If you're a sustainability manager, you probably already know this, but we will ask you to continue holding those monthly metering check-ins with the project teams. 30 minutes or less is all we're asking, and it really helps ensure the success of the program. And then the other thing is to help provide project support, whether it's, you know, we're still missing this quote for this meter, or we need this document. Helping being that link is going to be really important for the success of it. If you're a field engineer, we're going to ask you to collect the data and enter it into the BuildingOS platform. I kind of alluded to how easy it was to enter it in. I think the data collection is the one that you might need to plan on spending a little bit more time on, which is just, you know, basically getting the fuel tickets from the subcontractors and tracking down the utility bills, maybe from your accountant. And then the other thing is to attend those metering check-ins with your superintendent. Project manager, the ask for you is to review the dashboard data with your teams. Again, we don't want to just have this data available and nobody look at it. We don't want it to just be in the lap of the field engineer. We would really like whole team engagement. And so we're looking to project managers to help facilitate that. And of course, if there's any reduction strategies that have been identified, you have that $5,000 hold to help offset the premiums associated with that, but helping enforce those reduction strategies and monitor their success on the job site is going to be really important. And if you're an ops manager, your job will be to confirm metering candidacy for each of the projects as they come to your desk, and also check in on the status of metering during the ORMs. And this doesn't mean, are the meters installed? It also means, please, you know, show me the data. Let's walk through it. Why is there a spike here, etc. Okay, so let's go ahead and wrap it up. I wanted to first point out that there is a page on TKN that's intended to be a resource for you. If you haven't been to the sustainability page on TKN under resources, a lot of really awesome stuff there. There's a whole laundry list of resources off to the left there. We're not going to send you out into the world with no templates or resources. So we will make this clear to you in our kickoff call meeting, but just know that this exists here as well if you have any additional questions. And then to kind of end it on a high note, we just wanted to point out some of the best practices and the perks of what we've been seeing in the field. Number one is a really great practice is to just talk about the data, throw it up on a screen during the ORM and in staff meetings. So again, it's not just the field engineer looking at the information, that it's the whole team addressing it, getting normalized to what an average job site consumes in terms of tons of carbon or gallons of water, and really collaborating as a team to start working ourselves towards that 50% reduction. And another great practice is, you know, this is really intended to be thrown up on a wall and viewed as you pass by. And so if you have trailers or trades walking into the trailer, if you have an owner walking into the trailer, you can all take a look and start thinking about how can we collaborate to reduce this number and increase sustainability awareness on the job site. Some of the perks that we've been seeing, we've been identifying a lot of waste that's been happening. And again, when you say the kilowatt hour, it's not just the tons of CO2 associated with it, it's dollars. So this can actually help pay itself off if used correctly and actively reviewed as a team. You can increase team engagement surrounding job site sustainability. And actually, there's potential for getting a lead innovation point for all of this work that we're putting in. Turner is a platinum member of USGBC, and we're hoping to standardize a pilot credit associated with this effort. And so once that gets passed, we're really hopeful that that'll become a standardized point for lead projects. But in the meantime, you can still submit this for an innovation point on your project, and your lead consultant can help facilitate that. And if you have any questions about that, don't hesitate to reach out. So we can go ahead and open it up to questions. I will also in a bit throw up the fact that we do have a way to, you can report this as a lead continuing education credit. So I'll throw that up on the screen once we get near the end of questions. But Monica, I'm not sure if you've been monitoring the chat. Do we have any good questions?
Yeah, I have. Julia has done a great job answering some of the questions. So I just wanted to make sure folks are, if you're not keeping up with the chat, Vitality ships to Canada, and hardware is purchased and can be reused in subsequent jobs. So here's a question that comes from Steve. What about fuel sharing? Fuel trucks can show up and fill lifts, booms, generator, excavators. So basically fuel that is shared among many trades. How do we handle that?
Yeah, so I can answer that. More important than anything else is to get total fuel use from start to finish on the project. Ideally, we segregate it by use. So if you have your site work guys bringing their own fuel and your steel guys bringing their own fuel, you can easily distinguish between those. That's ideal because it helps us understand what the biggest chunk of the pie is. However, some job sites don't allow for that. In those instances, we'll take what we can get. We'll just be getting those fuel truck data tickets from the fuel trucking company. Typically, Turner pays for it ourselves in those instances. And so we'll take that information and we'll upload it. Unfortunately, we'll lose some of the granularity associated with it, but it is what it is. More important, shovels in the ground to substantial completion, total consumption.
Cool. Thank you, Emmy. And we have a question from Jason. Can you share how the Turner projects that are under 10 million will be captured in the baseline emissions calculation and then eventually our overall calculation for hitting our 50% goal?
Yeah, so when we talk about projects that are under 10 million, typically what that looks like is a TI project. And we don't have too many TI projects in our baseline calculation. When we say we're going to reduce by 50%, the good follow-up question to ask is from what? And so that baseline of what we're establishing a 50% reduction from is any project that has a start date before December 31st of 2020. So all the projects that are going to be part of that baseline set have already been identified and started. We don't have too many TIs, but we do have some TIs that fall under that $10 million range. And so when we set our baseline, when we're in the future and we're ready to reduce, it will be inclusive of those TI sets that are under that $10 million range. The identification process for $10 million and under projects going forward is really going to be kind of ad hoc as they show up. So when we identify projects for metering, we actually run a log from CRM for any project that's over $10 million. And so those are the ones that show up on headquarters radar that will be actively pursued. Anything that's under $10 million though is not going to show up on that list. So we're not going to be going for every $500,000 TI that shows up. If there is, for example, though, an $8 million project, really green client, project team really wants to do metering, that project team will have to bring it to the sustainability manager to say we want to do this rather than the other way around.
Thank you, Emmy. And I encourage everyone to continue typing questions if you have any on the chat. There was a question regarding dust control and noise pollution and vibration monitoring, and that being a major concern, and if that is included in our goal. And I'm going to take a stab at it and say that it is a major concern for projects near residential or retail complexes, but it's not something that is addressed in our Turner 2030 goal. So
the one. Yeah, so the only one of that list that I would say would be captured would be dust control. So if you do have street sweeping that goes outside of the project boundary, those tend to use a good amount of water. We would want to capture that. And the fortunate thing about that is a lot of times those trucks fill up using the site hydrants or they truck it in and it's fairly easy to measure. So we will be seeking that information. From a noise monitoring and a vibration monitoring perspective, because it doesn't directly impact, the tons of carbon for a job site or the amount of water used, it would not be counted towards our 2030 metering program.
Yeah, I mean, I will say that we're always looking for good solutions though to those types of problems, those types of environmental considerations, right? So last year we implemented our no idling standard company-wide, which is really there's an emissions component to it for sure, but there's also air quality components involved there. That really speaks to the health of our workers that are on our sites every day. So we'll continue tackling some of, we're open to continuing to tackle some of these topics that influence our sites, even if they are a little outside the boundary of our 2030 commitment.
Ladies, I don't see any other questions on the chat. Last call. Oh, there's one more. This question comes from Aranga, and he asks, how does the coordination look like for the metering equipment at the end of the project? It's a good question.
It's a great question. So we can reuse this equipment, which is one of the great things. So since we've had a few projects kind of end and start since we started the program, we've actually started doing this a little bit more. But I mean, we don't want to just throw these things out at the end of the project if there's another project that's willing to use them. So what that'll basically look like is we'll start with a regional approach. If there are any projects starting regionally that need meters that can use the hardware from your project if you're finishing up, your sustainability manager for that region will reach out and say, we need all of the hardware that you can give us. Can you please send it over? And it's typically as easy as, here's our address. And then, the project coordinator helps package it up and send it out. That's typically kind of what that looks like. Hopefully in the future, we can have kind of a more streamlined way of doing it. But if there are no needs in the immediate region, sometimes what we'll do is we'll send it out to other regions if there's a need elsewhere within the company. So that's how that typically works.
Emmy, can you go back to the resources slide of what's available on TKN? Because we've had several committees working on some of these documents and resources that are available to you to make this as easy as possible. And so really, really great documents there that really kind of set you guys up for success. There's subcontractor scope language, there are process maps, there's an info sheet for clients that want to know more about our program. There's a BuildingOS user guide. So do go into that link that Monica posted in the chat and poke around and see what's there and available, because there are lots of things that will really help answer the frequently asked questions. And then, Emmy, if you want to go to the education credits. Yeah, so this will, as Emmy mentioned, we're watching today, you can self-report and get one continuing education credit if you are a LEED accredited professional. And with that, I think we can wrap up early. You can reach out to myself or to Emmy if you want to go back one more time, Emmy, to the slide with our email addresses on there. But for day-to-day coordination, how to get your program started, please reach out to your sustainability manager in your BU, and they can help get the launch started. The list of sustainability managers is also on TKN if you don't know who that is in your office. So please and thank you guys for your cooperation, participation, and we're really getting some really impactful data coming out, and we'll continue to share reduction strategies and ideas over the course of this year to help really spur us towards our 2030, meeting our 2030 commitment.